Hello, everyone. My name is Kevin Tarr. I am an iOS engineer, and today is day 29 of Algorithms in Swift. We're almost done. And we're going to be playing another game of Tic Tac Toe. No, I'm just playing. But we're going to be using Tic Tac Toe to solve another problem. Instead of counting how many X's there are in the Tic Tac Toe board, we're actually going to find out the winner of the Tic Tac Toe game. This is going to be pretty challenging because, again, we're dealing with arrays of arrays. But remember how we flattened the array yesterday? Then that should be of great aid to you and helping to conceptualize how we can solve this problem going forward. But this is going to be fun. This problem, again, is another Mirage problem that appears much more challenging than what it is. But with functional programming, I think that we could definitely come up with a very straightforward solution to this problem. So let's begin. So our problem states create a function that detects whether either player has won in a game of tic-tac-toe. A tip here at Tic Tac Toe is a board that's 3 by 3 containing single letters that are either X, O, or empty. A win is 3 X's or O's in a straight line. So guys, we're going to go straight into a visualization so I can give you more clarity on how we're going to solve this problem. Let's begin. So the best approach to solving this problem is by visualizing a tic-tac-toe board. And not just specifically X and O position on the board, but zeroth index ordered position on the board. The same way computers visualize arrays, by zeroth index. By seeing where X's and O's are in relation to the zeroth index position on the board, we can easily create number schemes that create winning combinations for tic-tac-toe. We can see here that 0, 1, and 2 is a winning combination. We can also see that 1, 4, 7 is a winning combination, as well as 2, 4, 6, so on and so forth. Now that we understand the tic-tac-toe board and how that helps us in regards to the array of arrays and the indexes and our number patterns here, let's start solving a problem right now, okay? I'm going to put this array of arrays here just so we have something to reference for our winning combinations that we're going to do. And pretty much what we're going to do, and let me explain this approach a little bit more, we're going to the array of arrays, we're going to use functional programming to flatten the entire array of arrays, to collapse the entire hierarchy of the array of arrays to make it one giant array with all the X's and O's in one single array, just like we did yesterday, okay? But what is going to be fascinating about this is we're going to check for the winning combinations in the array. So we're going to find the array index, the X's and the O's in the index numbers. And we're going to compare that to winning combinations like 0, 1, and 2. We're going to see if there's an X at 0, 1, and 2 of the array of arrays. At the flattened array level. If there's an X at 0, 1, and 2, that means we have a winning combination. Or something like 0, 4, 8, if we have X or O there, we have a winning combination. So we're going to put all those combinations in a dictionary, loop through the dictionary because dictionaries are constant time, so they're very, very fast and they're very time efficient. And we're going to check where an X or O is and see if that lines up with a winning combination or a winning line with the number indexes on a tic-tac-toe board. If we have a winning line or winning combination, then we have a winner. We can return true. If we never find one, we can return false. So let me start writing, and if it's not clear to you, it will be in just a short moment. Okay. So we're going to make an array of arrays. It's called strings. We're going to return a Boolean. Of course, we're going to check to see if the array of arrays is empty to begin with. And if it's not, we're just going to continue. But if it is, we're going to return false. Okay? Then we're going to create a dictionary. We're going to call this winning combinations. And that's going to we're going to start writing the winning combinations here. So we know that 0, 1, and 2 is a winning combination. We're going to also put here 0, 4, and 8. We're going to then put 0, 3, and 6. Then we're going to put 1, 4, and 7. Then we're going to put 2, 5, 8. then 2, 4, 6. 3, 4, 5. And then for the last one, it's going to be 6, 7, 8. Okay? So that's the hardest part of this entire problem. Okay? Now we're just going to I'm going to call this flat end array. And we're going to flatten the entire game board. Okay? Then, okay, comma, sorry. Then we're going to just for loop through the values for a combination for indexes, indexes and winning combinations that values. The flattened array winning combinations of indexes 0 is equal to x. And we'll check that for 0, 1, and 2. Okay. Return true. And then we're going to check that for O. And we return true. And we go through the entire for loop and don't find anything that is, we don't find any winning combinations, we return false. So let's just do this really quickly. Let's put in this array. And that should return true. Yep, return true. I'm going to put in all these just to test our problem. Yep, return true. Let's get a third one. Return true. This should return false because it's not a winning combination. Yep, false. And this should also return false. False, yep. So this works. And if we want to just like actually, now if you really want to impress me, if you're interviewing with me, and you really want to impress me, and you want to like say, okay, let me actually reveal the winner between X and O, then you can simply do that by just returning the character. And even though this is just a small adjustment, this is actually a pretty significant way to show that you truly understand the problem. And it's a bit show-offy, but it's definitely bonus points that definitely show your coding chops. Okay, so we put here X should return true. Well, not should return true, it should return X. Yep, cool. So guys, this is a problem right here. This is a solution. Hope this helps you if you ever get this problem. This problem, again, it appears is one of the mirage problems. So it appears very complex, but it is not. If you actually flatten the array, you get rid of all the complexity of the problem, and it could be pretty solvable if you flatten everything and approach it in a straightforward way. Guys, my name is Kevin Tar. Thank you again for watching. Have a good night. Bye.